Welcome back, everyone. In today's video, we're going to dive into something super important: logging in Spring Boot applications. Logging plays a crucial role in helping you monitor, debug, and keep track of your application's behavior. Whether you're dealing with errors, performance issues, or just want to track how your application is doing, effective logging is your best friend. We'll cover how to configure logging in Spring Boot, explore the different logging levels, and show you how to get the most out of the built-in logging capabilities. Let's get started and unlock the power of logging in Spring Boot. Until now, we've been using system.out.println for logging, but let me tell you, that's not the recommended approach for production-ready applications. It's basic and doesn't give you the flexibility and power you need when it comes to logging. Today, we're going to step it up and use Log4j2, which is a more robust and scalable logging framework for Spring Boot applications. Log4j2 is highly configurable, allowing you to easily control how and where your logs get stored. You can choose to log to the console, files, databases, or even cloud services. The possibilities are endless. One of the biggest reasons for using Log4j2 is its performance. Unlike its predecessor, Log4j1, Log4j2 offers asynchronous logging, which makes it much faster and reduces the overhead on your application, especially when handling a large volume of logs. Log4j2 allows you to configure different log levels like debug, info, warn, error, and fatal. This is incredibly useful for controlling the amount of information logged in different environments, from development to production. When your application grows, the way you log information becomes crucial. Log4j2 scales with your application, handling large volumes of logs without slowing it down. Log4j2 is widely adopted and actively maintained. You'll find tons of resources, tutorials, and a vibrant community to help you troubleshoot and optimize your logging. So, why settle for basic logging when you can leverage Log4j2 to elevate your logging experience? Now, let's talk about log levels in Log4j2 and how they help manage the kind of information you log. Each level gives you a different level of detail. First, we have debug. This is perfect for when you're troubleshooting. You want to see all the detailed logs to understand what's happening behind the scenes. For example, when fetching user data for a particular user ID like user ID equals 123, you'd use debug to see that detail. Next up, we have info. This is for logging high-level progress. It's like checking in on how the application is doing. For example, after a user logs in successfully, an info log tells you that the process was completed successfully. Then comes warn. This indicates that something might be wrong, but it's not urgent yet. For example, if your disk space usage hits 85%, it's a warning for you to be cautious. Error is a bit more serious. This is when things go wrong and need immediate attention. For example, if the database connection fails, that's something you should log as an error. And finally, there's fatal. This is used in extreme situations when something goes horribly wrong, like when the system runs out of memory and needs to shut down. It's rare, but important to know. If you don't want any logs at all, you can use off, and if you want to log everything, all will capture everything, including all the levels. Using these log levels efficiently will make your debugging and monitoring a lot easier. Let's see how we can configure these in our application next. This engaging tone breaks down the log levels with examples, helping viewers relate the terms to real-world scenarios. Let's talk about the log level ordering. If you set the log level to off, no logs will be printed. If you set the level to error, only error and fatal logs will be shown, because error is the threshold, and anything above it like fatal will also be logged. Similarly, if you set the log level to debug, it will capture everything from debug and above, which means debug, info, warn, error, and fatal logs will all appear. But if you set it to info, only info, warn, error, and fatal logs will be printed. This way, you can control the level of detail in your logs depending on what you need at the moment. Alright, let's dive in. First, let's quickly clean up something from yesterday. Remember, we enabled the dispatcher servlet logs for detailed tracking? Those were useful for debugging, but we don't need them cluttering our logs anymore. Let me open the application.properties file and remove the line where we set logging.level.org.springframework.web.servlet equals debug. Now, let's move to the demo controller class. Here we already have an API called header1 that we created earlier. We'll use this API to test logging. Let me open the class and show you the method. Now, as you can see here, We're currently using system.out.println for logging. But this is not the recommended approach for production-ready applications. So, let's migrate this to Log4j2 and see how we can implement proper logging. Watch closely as we make these changes. Alright, let's start by opening the pom.xml file. This is where we'll add the necessary dependency for Log4j2. Alright, take a look at the screen. Here in the pom.xml, we have the Spring Boot Starter Web dependency. Now, this dependency by default includes Spring Boot Starter logging, which brings in Logback as the default logging framework. But we're moving to Log4j2 for better flexibility and performance. To do that, we need to exclude Spring Boot Starter logging from this starter dependency. Let me show you how we can achieve this step by step. Watch closely as I update the configuration. Add an exclusions tag right here. And specify group ID as org.springframework.boot and artifact ID as Spring Boot Starter logging. Add the Spring Boot Starter Log4j2 dependency. Alright, now that we've added the dependency, the next step is to reload the pom.xml. Now, let's move on to creating the logger object. One way to do this is by manually defining the logger in our class like this. Logger log equals loggerfactory.getLogger, democontroller.class. This creates a logger instance that we can use to log messages. Another way to easily use logging in Spring Boot is by leveraging Logback at Log4j annotation. This annotation automatically provides us with a log variable for logging, and we don't need to manually define a logger object. The log variable is automatically created with the class name as the logger name. Since we've already added the Logback dependency in our project, all we need to do now is simply add the at Log4j annotation at the top of our class, and Logback will handle the rest for us. Remember how we discussed log levels earlier? Well, now let's put that into action. Let me show you how we can replace our system.out.println with proper logging levels using log.info. Alright. Let's make sure we add all log levels for testing and debugging. First, we'll use log.debug for debugging messages, which gives us fine-grained information that helps track down issues. Next, we'll use log.warn to log warnings. These are for situations that aren't critical but could cause problems down the line. Finally, we'll use log.error when something goes wrong or needs immediate attention. Alright, now that we've added the logging statements, let's start the server and see how everything works in action. Alright, the application is up and running. First, let's clear the logs to make sure we only see the fresh logs from our API call. Now, I'll switch over to Postman to make the request and trigger the logs we've set up in our application. Let's hit the API endpoint and see how the logs reflect the different log levels based on the request. Now, as you can see in Postman, the response has successfully arrived. Let's switch back to IntelliJ to check the logs. Now, as you can see in the logs, we have the info level log for the header being printed, which is expected. After that, we tried to print a debug log. But hold on. There's a warn log printed instead of the debug log. Why is that? Well, that's because the default logger level was set to info, so only info level and above, warn error were printed. Since debug is a lower level than info, it didn't appear in the logs. So, the debug log didn't print because our logging level was higher than debug. But don't worry, we can easily change that. Next, as we can see, our error log has also been printed as expected. Pretty interesting, right? So, if you want more detailed logs, you'll need to adjust the log level to debug or trace. Did you know that you can easily configure log levels in your application.properties or application.yml files? But here's a better idea. Let's keep our logging settings separate for more flexibility. We'll create a dedicated configuration file, log4j2.yml, just for managing our logs. This approach gives us more control over how logs are handled, and it's cleaner too. Let me show you how we can set this up. Let's create the log4j2.yml file inside the src/main/resources folder, where we'll define our custom log levels, patterns, and other log configurations. Alright, let's dive into configuring log4j2. We're going to define the log4j2.yml configuration file, which is where all our logging magic happens. Add configuration as root element. Next, we'll move on to define the appenders and loggers. An appender is essentially where our log messages will go, whether it's the console, a file, or even a database. Today, we're focusing on a console appender for simplicity. Here's where we set up the console appender. Think of this as the output stream for your logs. They'll be printed right in your terminal or console. Log4j2 offers a variety of appenders, like file appenders and rolling file appenders, but for now, we'll use the console appender. It's a clean and quick way to see logs in real time while testing. Now, let's take it up a notch. We can add multiple console appenders if needed. Let's define first console appender. First, let's give it a custom name. You can name it whatever makes sense for your project. In this case, we'll call it console appender. Next up, we'll specify the target. This is where we want our logs to appear, and here, we're choosing system_out so that the logs show up on the console. Now, we add something called pattern layout. This is a key part of customizing how your logs are displayed. In the pattern layout, we define the pattern that tells Log4j2 how to format each log line. Add %d, which represents the date and time for the log entry. Now, we specify the format for the timestamp. We can do that by adding YYYYMMDDHHMMSS. Next, we're going to add %-5 level to the pattern. Here's what it does. %level is the placeholder for the log level, like info, warn, error, or debug. The -5 part means it will left align the log level within a 5-character whitespace. So if the log level is shorter than 5 characters, like info or warn, it'll automatically be padded with spaces on the right to make sure everything looks aligned. Next, let's add %t to our log pattern. What %t does is quite interesting. It represents the name of the thread that generated the log entry. So, if multiple threads are involved, you'll be able to see exactly which thread the log message came from. This will output the name of the current thread wrapped in curly braces, like main or worker thread 1, depending on your application's threading. This helps when you're debugging multi-threaded applications, giving you more context on where the log message is coming from. Next, let's add %c%m to our log pattern. Here's what this means. %c is the logger's name, which is usually the class name where the log entry is created. And %m represents the method name in which the log statement is placed. So, when you look at the logs, you'll see something like com.example.myClass.myMethod. This helps you trace exactly which class and method the log entry is coming from, making debugging and understanding the flow of your application much easier. Next, let's add %x to our log pattern. So, what does %x do? It represents the mapped diagnostic context, MDC, which can hold custom key value pairs. These key value pairs are helpful for adding extra context to your logs, like a user ID, session ID, or request ID, making your logs even more informative. Next, let's add %message. Now, %message represents the actual log message that you want to log. This is the content of the log entry, the core message you're recording, such as a status update, error message, or any specific information you're logging during the application's execution. Now, let me explain the final part of the pattern we are using in the configuration. We add %n, which stands for a new line character, new line. This ensures that every log entry is printed on a new line, making the logs more readable. Without this, all logs could run together in a single line, making them hard to distinguish. Now, we have defined one console appender. In the same way, we can define another console appender. For example, let me copy this appender and rename it to console appender without second. Next, we can modify the timestamp format by removing the seconds part from it. This means the new format will only show the date and the hour, like this, %DYYYYMMDDHHMM. This gives us flexibility to use different logging formats based on our needs, such as one with full timestamps and another with a simpler, more compact format. Alright, we've set up the appenders, but hold on, that doesn't mean the logs are automatically following this configuration yet. Now, let's take it to the next step and add the loggers. Think of loggers as the directors of our logging system. They decide which appender to use for the logs we generate. By defining loggers, we're basically telling Spring Boot, hey, when you print a log from this class, use this specific appender and follow this pattern. Let's jump into adding the loggers and bring everything together. This is where the magic happens, and our logs get the right treatment they deserve. Now, let's define the loggers. Under the loggers section, the first thing we add is the root logger. This is the parent logger for all other loggers. In the root logger, we set the level, which is where we specify the log level, like info, debug, error, etc. This ensures that all logs that fall under the root logger will adhere to this level. Next, we define the appender ref. This tells Spring Boot which appender we want to use for the logs. In simple terms, we are pointing to the specific appender we configured earlier, so the logs follow the pattern and format we specified. So, let's set up the root logger and link it with the appender. For this, we will use the console appender that we defined earlier. By linking the root logger to this appender, we'll ensure that all logs are printed according to the format we specified in the appender. This means the logs will be displayed with the date, log level, thread name, class and method name, and the message, all formatted just the way we want it. Let's apply this configuration now. Now, let's say you want different appenders for different loggers. For example, one logger could output to a file, while another could output to the console. To achieve this, we need to define separate loggers in our configuration. Now, let's add the logger configuration under the loggers section. Just like we defined multiple appenders earlier, we can define multiple configurations for different loggers here. Each logger can be configured with different settings such as the log level, appender to use, and whether it should propagate its logs to the parent logger. Now, let's add the name. The name here corresponds to the logger object we created earlier in the code. Remember, we used the fully qualified class name for the logger's name. This is the same name that needs to be specified here. But here's an important point. If you have multiple classes and you want them to use the same logger configuration, you don't need to define a logger for each class. Instead, you can use the prefix part to apply the logger settings to all classes within a specific package. For example, if we want to apply this logger configuration to all classes within the com.gan.derpun.employee package, we can specify that prefix here. This way, every class under this package will use this logger configuration. Next, we'll add the level for the logger. The level determines the severity of the log messages that will be recorded. For example, you can set it to info, debug, or error based on the kind of logs you want to capture. Next, we add additivity. This property controls whether the log messages should be passed to the parent logger as well. By default, it's true, meaning that logs from this logger will be passed up to the root logger. If we set it to false, the log messages will only be handled by the specific logger we're configuring and will not propagate further. Now, let's add appender_f. This is where we specify which appender to use for this logger. In our case, we have defined a console appender, so we will reference that appender here. Appender_f tells Log4j2 to use the specified appender for this logger, ensuring that the log messages are handled and output in the way we've configured. First, let's set the log level to debug in the log4j2.yml file. This will allow us to see detailed debug logs. Now, let's restart the application to see the changes in action and confirm that our logging configuration is working as expected. As we can see in the logs, there's a message indicating that a dependency is missing, which is why our configuration isn't active. Let's first check if it's working or not. To do that, we'll clear the logs and open Postman to make a request. Now, let's hit the request in Postman and then switch back to IntelliJ to check the logs. Oops! Debug logs still aren't showing up, which means our custom configuration isn't being used. No worries, let's fix it. Open the pom.xml file. We need to add another dependency to enable reading the YAML configuration file properly. Now, let's add the Jackson data format YAML dependency to our pom.xml. This is required for Spring Boot to correctly parse and use the log4j2.yml configuration file. After adding the dependency, make sure to reload the pom.xml, so the changes take effect. Once that's done, restart the application. It seems we might have made a small mistake in the log4j2.yml file. Most likely, there's a spacing issue in the configuration where we defined or referenced our logger. YAML is strict about indentation, so even a single missing space can cause problems. Alright, now that we've corrected the issue in the log4j2.yml file, let's restart the application again and verify if everything is working as expected this time. This time, as you can see, there's no error in the logs. It seems our configuration has been picked up successfully. Whoa! Just look at the logs, this time, it's flooded with entries. Why? Well, we set the root logger to debug mode, which means every debug level log from Spring and all the underlying frameworks is being printed. It's like opening the floodgates of information. Alright, now let's hit the API again. Check out the logs. This time, our debug log has successfully printed. Looks like our configuration is now working perfectly. Now, let's dive deeper into the log line. As per the pattern, it starts with the date and time, followed by the log level, which tells us the severity of the message. After that, we have the thread name enclosed in curly braces, showing which thread generated the log entry. Then, we see the class and method name where the log was created, which helps us quickly identify the source of the log. Next, if we look closely, you'll see that we have curly braces around the %x part. This part is for the mapped diagnostic context, MDC. In our case, we haven't added anything to the MDC yet, which is why it's not showing up here. But in real-world applications, this is super helpful for debugging issues. Finally, the log message itself comes through, which in our case is the actual log output, providing us the details of the event or action. Now, let's quickly change the log level to info in our log4j2.yml configuration and test it again. This will filter out any debug level logs and show only info, warn, error, and fatal logs. And restart the application. Hit the API again. As you can see in the logs, this time the debug logs have been filtered out. Only info level and above logs are being displayed. This shows how effectively we can control the log output based on the log level set in the configuration. We've created 2 appenders, and you can test them with different combinations as well. Feel free to try it yourself and experiment with different configurations. The video is already getting quite long, so we'll wrap it up here. To summarize, today we walked through setting up loggers and configuring them in Spring Boot using Log4j2. We learned about appender definitions, logging levels, and how to format our log messages. In the next video, we'll discuss rolling file appenders, which allow us to manage log file sizes and rotation. If you found this video helpful, make sure to hit that subscribe button so you don't miss the next one. Thanks for watching.